All right, thank you, Kari, and thanks everybody for being here. My name is Tracy Kugler, and I am the project manager for IPUMS IHGIS. I'm glad you've all joined us and you're all interested to learn more about IHGIS. I'm going to go ahead and pause my video so I can get that out of the way for you, and then we'll go ahead and get started. All right, so just a little bit on Zoom logistics to start. The webinar is being recorded, as you were informed by the lovely robot voice, and it will be posted to the IPUMS webinar page as well as to the IHGIS webpage, so you'll be able to find it afterward. We have closed captions being auto-generated, and you can turn those on or off with the CC button in your Zoom controls down at the bottom of your screen. If you have questions about technical questions about Zoom, anything that's doesn't seem right there, you can direct those to Kari, who is labeled as IPUMS in the chat, and she's happy to answer those questions. If you have questions about IHGIS, the substance of what we'll be covering in the webinar, please submit those via the Q&A function, which is separate from the chat. That just helps us to keep track of them better and to know what we've answered. And we will be taking any questions that are posted there or are asked in any other way, and we'll be compiling them into a written Q&A document that we will post along with the recording after the webinar. For the rest of the time here, I'm going to go through a bit of background about the project itself, where it came from, what data we have, and a little bit about what it looks like. And then we'll go into a demonstration, which will start with getting the data from the IHGIS website. And then we'll talk about what you actually get in your extract and some tips and tricks for working with the data in R and in QGIS, and we'll demonstrate working with the data in those two packages as well. So IHGIS is a collection of international population and housing census data, as well as agricultural census data. The data we draw from are published tables that are, most of what we have were published in PDF documents that were posted to the National Statistical Office websites. So we get these census reports and we pull the tables out of them, and that's what we process and make available via IHGIS. So it's typically place-based data where your records are districts or states or provinces, whatever the geographic divisions within the country are. And to go along with those, we also have the GIS boundary files that allow you to connect the data tables to the GIS boundary files to do spatial analysis and mapping. The data are available through a data access system, which we'll look at a little bit later. It allows you to browse the data tables that are available, select the ones that are of interest to you, and then you download a customized data set that has those data tables you selected along with complete metadata describing the tables. As with all IPUMS projects, the data are completely free of charge. Within IPUMS overall, we have 4 projects that deal with census data. So these are complete enumerations of the population in the country at a given time. And those kind of fall out in 2 dimensions. So we have international census data in IHGIS and IPUMS International. And we have US census data in NHGIS and IPUMS USA. IPUMS International and IPUMS USA are microdata projects. So the records in those 2 projects are individual level records or household level records. So you get a person's complete responses to all of the questions in the census enumeration form, and that's your record in the microdata. And for those projects, you get a sample of all of the respondents to the census. So ranges usually between about a 2 or 3% sample, typically a 5% sample. Some range up to 10 or even a denser sample in the microdata project. In the tabular data, you get the published aggregations of all of the complete enumeration. And those are for geographic units. So if NHGIS has states, counties, census tracts, blocks, block groups, census places, tribal areas, all of the US geographic units, and IHGIS is along those lines for different countries. So IHGIS is one of our newer projects, and it kind of fills in this corner of that international aggregate data. One of the motivations for starting IHGIS was to fill in the map of our population data. So we have in IPUMS International, because they're dealing with the microdata, the individual level data, in order to get access to and have permission to disseminate those data, we have to have agreements with the national statistical offices in each individual country that we're providing data for. IPUMS International has done a lot of legwork to get those agreements in place. They have them with over 100 countries at this point. So all of these countries in the kind of brown and tan are countries where we have agreements to get access to the microdata. But that still leaves 100 or so countries where we don't have any population data in IPUMS International. Those are the countries that you see in green here. So those are the areas that we've been particularly targeting in the early stages of IHGIS to help us fill in and get access to the microdata or to population data for those countries. We also have some countries where the microdata geography is quite coarse. So you can see the countries in the darker colors here where we might have just basically state level identifiers in the microdata. And we can often get much finer geographic detail in the aggregate data. And that is true even in the cases where we have second level or like county equivalent data in the microdata. Our agreements with those countries typically stipulate that we can't provide geographic identifiers for units that have a population lower than a certain threshold. Often it's 20,000 people. So in the microdata, units that are below that threshold end up getting combined with neighboring units until we get above that threshold into what we call regionalized units. So here on this map, the black lines are the regionalized units that are identified in the microdata. The green boundaries are the original municipal units. So those are the second level in the Dominican Republic. And you can see, especially in the western part of the country here, there are quite a few cases where we have to combine 2 or 3 or more original units in order to get above that population threshold. So where we started with 156 municipalities, and those are available in the aggregate data, we end up in the microdata with just 93 regionalized municipalities. And as you'll see in our demo later, we actually have third and in some cases even fourth level units available in the aggregate data as well. This just summarizes the data that we have currently available in IHGIS. So we have 30 data sets, almost 1,500 tables to date, and those cover both population and agricultural censuses. We have a couple of countries right now where we have both the Cook Islands and Albania. And you can see the list of the countries over here. And we are kind of in the practice of releasing new data sets more or less as they're ready. And usually those come out in batches of 2 or 3 data sets several times a year. So keep an eye on the website for anything that pops up. And if you are particularly interested in a particular place, we do have a lot of data that's in the pipeline, and we're always happy to kind of prioritize things according to users' needs. So let us know and we'll kind of see what we can do about getting those priorities adjusted. The data that we have in IHGIS, as I mentioned, are published data tables. And the biggest challenge with this project has been taking these data tables that come in a wide variety of different structures and getting them into a standard structure so that it's easier to work with in your analysis. So we might have geographic units on the columns, we might have geographic units in the rows, we can have different levels of categories and subcategories, different types of cross tabulations where you might have one set of categories on the columns and another on the rows, maybe broken up across different tables. So pretty much every kind of structure that you can imagine shows up somewhere in these results documents. But our goal is to get them all into a standard structure. So with everything that you get out of IHGIS, you know what to expect and how it's going to be structured. So everything that you get in an IHGIS extract will have geographic units on the rows, and we'll have the complete parent-child hierarchy information about each of those units. We'll also have the GIS join codes that allow you to link them to our shapefiles. And then each of the columns will be a data column that might be a count of people in a particular, with a particular set of characteristics, or a percentage, or some other aggregation that summarizes the population in that place. So these are two quite different censuses, from Sri Lanka population census and a Uganda agricultural census, but the data all looks the same when it comes out. We also provide extensive metadata. So you get, with your extract, you get a human readable code book that provides information on the data sets, the tables, and then the individual variables within the tables that you've requested. And we provide metadata CSVs as well, with the intent that these are kind of more human or machine readable versions of the metadata that you can use in stats or GIS software. And we'll show an example of what you might do with these during our demonstration. And finally, we have GIS shapefiles that are linkable to the tables on this GIS join code. So every shapefile that you get will include that GIS join column in the attribute table. You'll also have that column in all of your data tables so that you can easily join your data to the shapefile and do maps or spatial analysis. So I will pause here momentarily and take any questions about the project in general before we jump into our demonstration.
If anyone has questions, you can go ahead and post them in the Q&A now. Otherwise, Tracy, I think we're probably ready to, after a moment of waiting, ready to move on.
Okay. And we can always pick up any questions later as well. So we'll jump into our demonstration, starting with getting the data. So easiest way to get to IHGIS is to go to IPUMS.org. That's easy to remember. And then our project is right here. This is the IHGIS homepage, and we have a variety of information available here describing our collection and resources for using it. So we have data set descriptions that list each of the data sets that we have available, with the number of tables and the geographic levels that are available within that data set. We have our shapefiles are available right now for download off of this site. They're not directly available through the data access system yet, but you can come here and get a download of a zip file for each of the geographic levels that we have available. We have a user's guide that you can access from here. And we also have frequently asked questions. that should answer a lot of what you wanted to know about IHGIS. Anything that isn't answered here, feel free to drop by our user forum or send us an email at ipums@umn.edu. To get data, we can go back to the homepage, click our nice friendly Get Data button. And if you've used NHGIS before, the IHGIS interface should look familiar. It's built actually on the same code base. So it's considerably simpler at this point than NHGIS. We have just one filter, which is data sets. So this will show you a list of the data sets that we have available by population censuses, agricultural censuses, and we have one that's kind of a combination of both. So for this demonstration, we're going to be looking at the Dominican Republic. And so we select the Dominican Republic, click Submit, and then we get a list of all of the data tables that are available for that data set. You can see there's 57 of them. So you can go to display 100 in our table, and then you can see them all. And you've got the title of the table over here. And for the purposes of the demonstration, we'll say that we are interested in the building materials that are used for homes in the Dominican Republic. And maybe we've got some population health data from a survey or from some of our own field research. And we're interested in the context of the buildings that those people live in their kind of neighborhoods and areas. So we will look at building material in the walls, ceiling, floor, and then location of the kitchen area or cooking room. And you can see that each of these tables is available for nation, regions, provinces, municipalities, and then the cooking area one is also available for municipal districts. Once you've selected your tables, you've got them listed in your data cart here, and you can click Continue. That will give you just a summary of the data that you've requested. And you can get a listing of the tables you requested, make changes here if you like. And you'll notice it tells you how many files you've requested. And for this extract, we've got 17 files for 4 tables. And that's because you get a separate file for each geographic level from each table. So these 4 tables are 3 of them are available for 4 geographic levels. The last one's available for 5. So that's where you get these 17 tables. And we click Continue, and we can add a description of our extract. And click Submit. And that will take you to your downloads page where you'll see that your extract has entered queued status, and you can see all of your past extracts as well. It's now started processing and should take, for this small data set, just probably under a minute to get that. There we go. So once that is completed, you'll have a link to download your tables, and you can do that here. And then we can go and look at what is in that extract. So this is the zip file that we downloaded. We expand that. So here you see those 17 data files that the extract system told us we were going to get. And those are named with the name of the data set, the table code. So you see we've got 4 tables here, AAJ, K, L, and M. And then each of those has the geographic level. That's the last part of the file name here. So we've got, for table AAJ, we've got geographic levels 0, 1, 2, and 3. So this is national, all the way down to municipal. And you can see for this last table, we've also got a G4. And then we've got our metadata files. Those are named with the number of your extract. So this was extract 55 for me. So that's that initial part and then the type of file. So we'll go ahead and take a look at the code book. And this is just a human readable text file that summarizes what is in your extract. So we've got our data set level information, including the title of the source document that these tables were drawn from and the agency that produced that. We have table level metadata for each of our 4 tables, including the title, the code that ties it to the data files that are in our extract, the geographic levels, and the universe. And then for each table, we've got a listing of all of the variables that are in that table. And these are designed to be kind of complete comprehensive labels so that you can really understand what's going on in this table. So this first one is occupied private dwellings by type, predominant building materials in the walls, and urban rural. So there's 3 dimensions in this table. Those dimensions are separated by these colons. So you have type, detached house, apartment, room in a tenement, etc. We've got the predominant building material in the walls, so block or concrete, wood, palm wood, etc. And then if you scroll down, you see we've got urban, and then farther down we'll have rural. So within some of these variables down here, you've got all 3 of those dimensions. So urban, block or concrete walls in a detached house. And then you can link those. So if you look at one of the data files, so the data files have the GIS join code, the geographic unit information, which looks kind of gross when you open the CSVs in Excel. Those would look better in a text document or other places with the accents and everything correct. And then you have the variable codes on your columns that link to the codes in the code book. And one of the things that we'll be showing in our R demonstration is how to get more readable labels on these columns for working with in your stats package and later in GIS. And in order to help do that, that's where these other CSV metadata files come in handy. So we've got a geog CSV, which just lists the names of the geographic levels. We have table level metadata. So that gives you the title, the number of the table in the source document, if you have access to that and you want to kind of look at the context around it, the universe, the geographic levels, the source publication name, and so forth. And then probably the most interesting one is the data dictionary, which has the variable level metadata. So you can see we've got those variable codes here, and then the full labels. We also have the data year and the universe and the aggregation method for each variable. So we can pause here before we jump into our R demonstration if there are any questions about the extract system or in general what you get in your extract.
Tracy?
Yeah.
We had a question in the Q&A that I thought other people might be interested in. The question was regarding the sources of shapefiles and if they're provided directly by the governments.
Great question. And No, the shapefiles generally don't come from the same agency as the census results documents. Sometimes we're able to get them from a separate agency in the government. Sometimes they are provided by the statistical office, but those are kind of the exceptions. We generally source shapefiles from some of the other kind of international boundary file projects like GADM or SALB, or there's a few other ones. And we take those and we do some research and try and track down the correct boundaries for the units that are represented in the census. So that is part of our processing as well, is to take shapefiles kind of from wherever we're able to find a source shapefile and link them to the units that are described in the census. Any other questions? Okay, let's move on to what you can do with these data. And we're doing our demonstrations today in R and QGIS as kind of open source data package, software packages that are free and anyone can have access to. You can, of course, use these data in other statistical or GIS packages as well in much the same way. And as we mentioned, the code for this R code will be made available along with the recording. So and I'm going to just walk through the code here. Don't feel like you need to read the code. I kind of have signposts here for the major sections of kind of what's going on. So what we'll be doing in general is we'll be reading in one of the data files, and we'll be doing some transformations with the metadata files to get some better labels on those codes. And then we'll be doing a little bit of data exploration and finally exporting a kind of clean file for use in QGIS. So the first part of the script is just kind of setting things up. So and this is an R project file. So we saved the extract file into the same directory where our project is, so we can have direct access to that. And we're referencing the unzipped version of that extract. So for the demonstration, we're going to go ahead and work with the floor file. So if we look at, we can look at the code book in R and we don't have to leave. So the building material on the floor, that's table AAL. So that's what we're setting up here. And we're going to look at the municipal level, the G3 level. We have an NA indicator here that doesn't really apply for this data set, but if you had looked at your data file and seen that there were dashes or asterisks or some other indicator that there were no data in particular cells, you could set that here and that will clean things up a little bit later on in the script. All right, so we're going to read in that data file. So we have our IHGIS data frame, and that looks just like that data file. So it's got the geographic units, and then it's got all of the data columns with their codes. And then we're going to go ahead and read in that data dictionary metadata CSV. So we have that in a data frame as well. And you can see we've got our variable level metadata in that. So we have all of our codes and labels, data year, universe, aggregation method, etc. Let me go back to that for just a second. So these labels that we have here, as I mentioned, those are kind of verbose so that you can understand what those data are, but they aren't going to make great column headers in actually working with your analysis. So we're going to do a couple things for those. We're going to take some of these longer category labels and shorten them. And then we're going to replace spaces with underscores and that sort of thing. So we have some longer category labels, and I have created a little substitutions file here ahead of time that gives a shortened version of some of those longer column or category labels. So we're going from room in tenement or back of a house to just room, so kind of abbreviating those. So we're going to go ahead and read in that substitutions file. And then we're taking our data file here, which is a wide file. And in order to join the metadata to that, we want to join on these, what are now column headers, but we need to get those into a variable themselves in order to join on that. So we're going to pivot this wide format into a long format. So that's what we're doing here. And that gives us a long version of that data frame. So we still have the geographic units here, but now we have the table vars all laid out in a column with their values. So this first geographic unit, Municipio Cayento Hermosen, has 200 and some data variables in it. And then we get to the next geographic unit and we start over at AL01. So we've basically pivoted that wide format into a long format, which then enables us to do a join of the metadata to that long format. And so now we have our variable labels and other variable level metadata attached to that data frame. And then the next section here cleans up those variable labels. So we make those substitutions of the shorter names for the longer ones. We clean up the spaces. We would clean up the NA values if there were any. There aren't in this particular data set. And so I'm just going to run those and then we'll take a look at that. So we now have kind of better behaved variable labels that we'll be able to use. And we've replaced spaces with underscores. We've got those shorter versions of the labels. And we've dropped the colons, but we've got the dimensions are now separated by 2 consecutive underscores rather than space colon space. And we can leverage that in our data analysis, which we'll be looking at next. As soon as we do one more thing. So we've got this long version. We want to convert that back to a wide format. So we're going to take those column labels or variable labels and now use those as column labels in the new wide format. So this data frame now we're back to the original form of our data where we've got our 155 G3 units and 223 variables. And those now have kind of understandable column headers. So now we'll move into a bit of exploration of the contents of this particular data table as an example. So we're going to first simplify this data frame, and we're going to take just the columns that are kind of the marginal subtotals. So we'll get the total number of dwellings that are in urban areas, rural areas, the total number of dwellings that are of each housing unit type, so detached houses, apartments, rooms, and then the total number that have each floor type. So that is leveraging this idea of the dimensions being separated by these 2 consecutive underscores. We're actually dropping all of the columns that have multiple dimensions to get just those marginal totals. And then we are going to convert the data values to numeric and calculate some proportions. So we now have a data frame that has just 29 variables instead of 200 plus, so it's a little bit more manageable. And we have these proportions calculated of the proportion of dwellings that are in rural areas, the proportion that are detached dwellings, the proportion that have dirt floors, and the proportion that have wood floors. So we can do some basic plots of those. So this is just looking at the proportion of dirt floors compared to the proportion of dwellings in rural areas. And there's not a real strong relationship there. We can also plot proportion of dirt floors against proportion of detached housing units. And that's a bit stronger relationship, which is probably not surprising because you're not going to have a lot of apartment buildings that have dirt floors. So that's maybe what we're seeing here. But it might be interesting to map this spatially. So we're going to, as our final step, we're just going to write out a CSV version of this simplified, nicely labeled data frame that we'll be able to import into QGIS. So any questions on what we've done in R here?
Tracy, we've had one question come up in the Q&A. The question is, have we also tried to do DBS scan, DBSCA and DB scan using geospatial data?
I'm not sure what DBS scanning is. Can we get some clarification on that?
This is Kari. I'm just chiming in and wondering, I think as a non-R user, the thing I'm always amazed by is the shocking number of ways to do different things in R. So I'm assuming this is just sort of a query about whether or not anybody's familiar with doing something similar with a different package, would be my guess. If the person who submitted the question, density-based spatial clustering with noise, DBSACN, is the clarification.
Okay, so that's an analysis method, I believe. So that would be something that you can do with the data. We're mostly just providing the data that are in the tables, so we aren't doing any analysis on our end. Hopefully that answers the question.
Another question has come in. Can these shapefiles be analyzed by IHGIS and all their software?
Absolutely, yes. So you could, if you wanted to do your spatial analysis in R, you can absolutely do that. You can bring the shapefile in and do simple features or however you want to do that. I'm just going to show it in QGIS, and you can do anything in QGIS you can do in ArcGIS as well. Any other questions? Okay, let's hop over to QGIS.
Tracy, before you start, there's one more question about R and wondering about if the IPUMS R package works for IHGIS.
We do not have IHGIS support in IPUMS R yet. That is something that is on our list that we plan to work on hopefully within the next year or so. Good question, thank you. Okay. So in QGIS, we can go ahead and add our, we should go get our shape files that we're going to need for this. So we're going to go back to the IHGIS website, and we'll go back to the geography and GIS page, and we'll get the municipalities G3 level shape files. And we're going to save those just in the same directory that we have our extract. And I'm also going to go ahead and grab the G4 shapefile in case we have time to play with that as well. Okay. Now back to QGIS. All right, so we can add those shape files as vector layers, and QGIS will work directly with zipped shape files, so you don't even need to unzip those. You can just download them and work with them directly. So we can add our G3 shapefile here. So we have our G3 units. So these are the municipalities. And you look at the attribute table, pretty simple attribute table on the shapefile. So you've just got the name of the municipality and the GIS join code. We also have the parent G2 unit on those. And then we can add our CSV file that we exported from R as a delimited text layer. So that's this one here. And that's just a CSV file with field names and no geometry. So we can go ahead and add that. And you'll see this has the column headers that we created in R, and we have those proportion columns as well that we calculated. So we can join that data to our shapefile. So we just go into properties and joins and add a join. And we're going to join that data table. We're going to use the GIS join field in both the shapefile attribute table and the data table. We'll go ahead and add all of the fields in the data table, and we'll just give them a shorter prefix here. So now if we open the attribute table of the shapefile, we've got our label, parent GIS join, and then we've got all of our data columns as well. So that means that we can map them. So we can go back to our properties and go to symbology, and we'll do graduated colors because we're going to do a proportion. So we'll just look at let's start with the proportion of detached housing units in each municipality. And we'll pick, let's do maybe a yellow-green. And I usually start with a Jenks classification and just kind of see what that looks like. So there's maybe some spatial patterning to detached housing units, maybe more in the West, not quite so much in the eastern part of the country. The main city is kind of down here, so that's going to be a lower proportion of detached housing units. And if we go to kind of our variable of interest here of dirt floors, maybe we'll change the color ramp. Oops, that is the counts. I want to do the proportion. So that looks kind of like that. And there are definite spatial patterns here. So you definitely have a greater proportion of homes with dirt floors, kind of the western edge of the country, right on the border with Haiti there, and spilling out into these are kind of the highland regions here as well. So I can pause here for any questions on the mapping. And then if there's a little bit of time, we can also take a look at the G4 units as well.
So Tracy, one question that came in on the chat was whether the shapefiles that we provide are projected, and I guess to elaborate on that, what coordinate reference system do the shapefiles come in, and is that consistent?
Yes, they all come in just WGS 84, so they are not projected. They're just geographic coordinate systems. Any other questions? Okay, so we've got a few minutes, so I'm just going to show what the G4 units look like here. So we've got a G4 shapefile. And you can see we've got, let's see, in the G3 units, we have 157 municipalities. In the G4 units, we've got 388, so more than twice as many units. And the data are not available at this granularity for all tables, as you saw when we were in the data extract system, but they are for some. So we have, and you can see kind of how much smaller these units are if we flip back and forth. So the data table that we had at the G4 level, I'm going to add that. So this is just straight from our extract. So this was table AAM we have at the G4 level. And since we haven't gone through that process in R of adding the nice column names, we'll just take a look at what is in this table in the code book. And this is we don't have as many variables in this table, so it's a little bit easier to keep track of. So we've got inside or outside the dwelling or does not have a kitchen area, and then broken down by urban rural. So for the purposes of the demonstration, we'll just take a look at kind of the proportion that have kitchen areas outside of the dwelling. So that's going to be AAM 003 divided by AAM 001. So we can join that table to our G4 shapefile. Again, that's on the GIS join field in both. And you can see our shapefile now has those AAM numbered columns in it. So we can do similar symbology that we did, but we're actually going to just do a quick on the fly calculation here. We'll do AAM, so that's dwellings with kitchen areas outside the dwelling divided by the total number. And we'll give that maybe a green color ramp. And this is what that looks like. So that has a similar spatial pattern to our dirt floors, but you can see a little bit more spatial granularity kind of up here on the northern part of the country and over here as well. All right, that is all that I have for the demonstrations.